Hey everyone! Today we're turning our character customization into the real deal, wiring every category, preventing outfit stacking with a clean, clear step, adding a back button for smooth exit, and dropping in color sliders, hair, ears, tail, eyes. Quick, satisfying upgrades you'll feel immediately. Tiny clicks, big glow up. All right, let's start. Before we dive in, quick confession. Game dev isn't always epic boss fights and explosions. Half the time, it's just me, my coffee, and 100 tiny clicks naming slots and maps until it all works. And honestly, that's where the real magic happens. All right, let's get started. All right, let's set up the pieces for live color control. First, I'm creating an enum called eOutfitPart. I'm adding 4 entries: hair, cat ears, tail, and rabbit ears. Using an enum keeps everything tidy and prevents string typing mistakes later. Now, in my third-person character, I'm adding 3 variables, all keyed by that enum. PartSlotNameMap is a map from eOutfitPart to name. This stores the exact material slot name on the mesh for each part. For example, hair points to the mesh's hair slot name. PartBaseMatMap is a map from eOutfitPart to material or material instance. This is the base material I want to start from for that part. PartMIDMap is a map from eOutfitPart to material instance dynamic. This will cache the dynamic material instance we create so we don't make duplicates every time. With that setup done, I'm creating a function called GetOrCreateMID. It takes a single input called part of type eOutfitPart, and it returns one value called MID of type material instance dynamic. Here's what the function does step by step. I start by trying to reuse work. I look up the incoming part in PartMIDMap using a find node. If a MID is already stored for this part, the branch goes true, and I immediately return that cached MID. That's the fast path, and it keeps performance solid. If nothing is cached, we need to create a new MID. First, I need to know which slot on the mesh I should use. I ask PartSlotNameMap for the slot name that belongs to this part. With that slot name, I call getMaterialIndex on the mesh so I get the correct element index for createDynamicMaterialInstance. Next, I decide which source material to use. I try PartBaseMatMap with the same part. If it returns a valid material, I'll use that. If it doesn't, I call getMaterialByName on the mesh using the same slot name. That gives me whatever material is currently assigned to that slot on the mesh. If for some reason that's still not valid, I can safely fall back to base_mat so the function never fails. Once I have a valid source material and a correct element index, I call createDynamicMaterialInstance. Target is the mesh, element index is the index I just looked up, and the source material is the one I chose. The result is a fresh MID tied to the exact slot for this outfit part. Right after creating it, I store that MID back into PartMIDMap under the same part key. This means next time we ask for this part, the function will find it immediately and just return the cached instance. Finally, I pass the MID out through the return pin. That's the whole function. Now, let me explain why we built it. When we add color sliders in the next video, we need a stable, per-part dynamic material that we can tweak in real time. This function guarantees we always get the correct MID for hair, cat ears, tail, or rabbit ears. It finds the right slot, picks a good source material, creates the MID once, caches it, and reuses it. The enum removes typos. The maps keep everything organized and scalable. And the fallback path makes the system robust even if a setup is incomplete. In short, whenever a slider moves, we call getMIDPart, grab the MID instantly, and set parameters like color or roughness without any extra wiring. Now we've created a new function in our widget called ColorCF. Think of this as the color change controller for our character. Whenever the player moves a color slider in the UI, ColorCF runs. Its job is to go part by part, hair, cat ears, tails, rabbit ears, etc., and update their material colors in real time so the player instantly sees the change. Inside the function, we use a for each loop to walk through our part array. Each item in this array is one of the outfit parts from our enum outfit part, like hair, cat ears, or rabbit ears. It's like saying, let's visit each part of the character one by one and repaint it with the color the player just picked. For every part, we call our GetOrCreateMID function. This either fetches an existing dynamic material instance, if we've already created one for that part, or makes a new one if it doesn't exist yet. Think of it like paint cans in real life. If you've already opened a can for this wall, just use it again. If not, grab a new one. The color slider gives us a simple value between 0 and 1, but that's not enough for a full color spectrum. So we use MapRangeClamped to convert the 0 to 1 value into 0 to 359, a full circle around the color wheel. Then HSV to RGB turns that wheel position into a color Unreal can actually use. It's like turning a rainbow dial and getting the exact color mix ready for painting. Finally, we call setVectorParameterValue twice, once for Midtone Color, the base color, and once for Midtone Shade Color, the shadow tone. This instantly updates the material color of each part, so as the slider moves, the hair, ears, or whatever part is selected changes color live. Perfect. Now let's set up those maps inside BP third-person character. In the PartSlotNameMap, we've added 4 keys from our enum outfit part: cat ear, tails, rabbit ear, and hair. Each key is assigned to the correct slot name on the mesh. For example, cat ear is linked to accessory_cat_ear_01_cloth. Tails to accessory_foxtail_1_cloth. Rabbit ear to accessory_rabbit_ear_01_cloth. And hair to N0hair00hair. Think of this map as a directory that tells Unreal which slot name belongs to which part of the body. When we say hair, it knows exactly which slot on the mesh to target. Then in the PartBaseMatMap, we mapped those same parts to their default materials. Cat ear is linked to MI accessory cat ear 01C. Tails to MI accessory foxtail 01. Rabbit ear to MI accessory rabbit ear 01. And hair to MI_N0_HAIR_00_HAIR. This map acts like our paint supply. Each slot has its own base material we can clone into a dynamic material instance when we want to change colors. This step matters because without these maps, Unreal wouldn't know which slot is hair or which material to start with. Now, when our GetOrCreateMID function runs, it can look up the correct slot and base material, create a dynamic instance, and apply color changes in real time. We've selected the hair color slider inside our widget and used its onValueChanged event. This event fires every single time the player moves the slider, even a tiny bit. Think of it like a dimmer switch in your room. Every time you slide it, the light updates in real time. The slider sends out a value, a number between 0 and 1. That number represents where the player's slider handle is, all the way left, 0, to all the way right, 1. We'll turn this number into a color later. Then we make an array with a single element, hair. Why an array if it's just one thing? Because our color shaft function expects a list of parts to update. If tomorrow we want to let this same slider also change the color of, say, cat ears at the same time, we could just add another part into this array. It keeps things scalable. We connect that array with hair and the slider value into the color impoverished function. When the player moves the slider, it tells ColorSSF, hey, go update the hair part using this new value I just picked. Inside ColorCMS, as we explained earlier, The value is converted from 0 to 1 into a full 360-degree hue range, using map range clamped and HSV to RGB. Then we grab the dynamic material instance for hair and set its color parameters, mToon color and mToon shade color. Why this is powerful. Instead of pre-making dozens of hair color materials, red hair, blue hair, green hair, we now let the slider drive the color in real time. The player gets instant feedback as they drag the slider, just like picking a paint color and immediately seeing the wall change.
Oh man, the color looks super weird right now when we move the slider. Definitely not what we want. Feels like we might have missed a tiny connection somewhere. Let's take a closer look together. Oh, there it is. We forgot to connect the setVectorParameterValue node to the HSV to RGB output. Because of that, the material wasn't getting any color data at all, so it defaulted to black. Such a tiny detail, but it makes a huge difference. This is one of those classic, one unplugged wire and everything looks broken moments in Unreal. Always double-check those node connections when something feels off. Most of the time, it's just one small wire missing. As you guys know, sometimes when we close and reopen the editor, we start getting that classic accessed none trying to read property error. It's Unreal's way of saying, hey, you're trying to use something that doesn't exist right now. Here's how to fix it. Go into your colorSef function and add an isValid node before the setVectorParameterValue nodes. Take the output of isValid and connect it to the execution pins of those setVectorParameterValue nodes. What this does is simple. It checks, do we actually have a valid material instance before we try to change its color? If it's not valid, Unreal just skips that step instead of throwing an error. Now compile and play. No more accessed none errors. Smooth and safe. All right, problem solved. Okay guys, now we're adding a brand new eyes color slider. First, just duplicate one of the existing sliders in the widget, for example, the hair slider, and rename it to eyes so we have a fresh control ready. Next, jump over to your enum outfit part and add a new entry called eyes. This way our system officially knows that eyes is a customizable part, just like hair, cat ears, tails, and rabbit ears. Now open your BP third-person character in PartBaseMatMap. Add a new map element for eyes and assign the base material your eyes should use. In PartSlotNameMap, add eyes and give it the correct slot name from your mesh, the material slot that controls the eye color. Finally, go back to your widget and select the eyes slider. On its onValueChanged event, hook it up the same way we did with hair. Make an array with the eyes enum value. Pass the slider's value into our colorCF function and connect it. Now hit play and test. Move the eye slider and watch the character's eye color update live. Looks awesome. Now our customization covers eyes too. Clap. All right, time to add a back button so players can exit the customization view like pros. First, drop a back button into the widget and style it however you like. Text, icon, rounded border, little hover glow. Make it cute. Now bind onClicked. Inside onClicked, use the BP_character reference we cached on event construct. We're going to swap cameras back, restore controls, and close the UI in one smooth motion. First, set your FOV camera inactive using setActive. Then set the follow camera active using another setActive. Think of it like walking out of the dressing room and back onto the game floor. FOV camera off, gameplay camera on. Next, give control back to the player. Call enable input using the player controller you cached. And if you showed the mouse earlier, set show mouse cursor to false and switch input mode back to game only. Finally, close the UI by calling remove from parent on this widget. Quick recap you can say while clicking. Back button pressed. Turn off the FOV camera. Turn on the follow camera. Re-enable input. Hide the mouse. And remove the widget. Clean exit. Little fun check before we celebrate. Hit play. Open the customization. Press back. You should snap from the close-up FOV back to gameplay. Movement returns. Mouse disappears. And the UI is gone. If anything feels off, double-check which camera you're toggling and make sure you're enabling input on the same player controller you used earlier. Pro tip: the back button is your graceful exit. Make it feel silky. A tiny fade or sound cue here goes a long way. And yes, I clap a little every time it swaps perfectly.
Okay, spot the tail. It's clipping and doesn't look great. Let's fix it fast in the animation blueprint so it moves naturally and stops diving into the clothes. Open the third-person character's enum blueprint. Add a VRMSpringBone node to the graph and wire it into the output pose. This gives the tail secondary motion with spring physics so it reacts smoothly when the character moves. In the VRMSpringBone settings, disable Ignore Physics Collision. This prevents the spring sim from doing weird micro-collisions that push the tail through the body or outfit. Compile and save, then hit play. Check the result. The tail should sway naturally, settle nicely after movement, and, most importantly, not sink into skirts or jackets. If it's still too floppy, lower stiffness slightly. If it's too stiff, raise drag a touch. Little tweaks here make a big difference. Looks way better now, right? Next up, we'll tidy the blueprint, swap our ItemId strings for a proper enum, and lock the system down so it's reliable and easy to grow. And a quick story before we wrap. The first time I demoed a customization menu, everything looked perfect. Until my cat strolled across the keyboard and swapped the outfit mid-sentence. I thought I broke the whole thing. Turned out the logic was solid. It just needed cleaner inputs. That's why we're polishing now, so even surprise playtesters can't knock it over. If this made you smile or saved you time, drop your tiny win in the comments and tell me what part you want to customize next. See you in the next one. Thanks for watching. If this helped, please like and subscribe.